Hey everyone! So in the past few days, we have started looking at logs and exponentials. And you guys have seen this before. So our log form and our exponential form. So remember the base and our exponential is right here. Whereas in a logarithm, that base shows up as a subscript. Remember here is where the exponents show up. And then a log, we call this thing, sometimes it's in parentheses. We call that the argument. So for example, let's say I had something like this. So this would be my base. This is the exponent. And then this is the argument. And remember, we say that log base 2 of 8 equals 3. And we also looked at putting it into exponential form, because remember, logs and exponentials, they're like peanut butter and jelly. And in order to put it into exponential form, we did that log rule. So remember, when we do a log rule, we always start at the base, goes to what it equals, and then what's left. So this would be 2 to the third equals 8. Okay. All right. There's usually 3 different rules of logarithms that we talk about. But I think for today, that just focusing on this one big one will suffice. Okay. So one of the big rules for logarithms is that x has to be greater than 0. Or in this case, let's say your argument has to be greater than 0. And I'm going to show you why here. Okay. So I have this example here. It's log base 2 of negative 1 equals x. So notice I have a negative argument right here, and I'm going to show you why we can't have it. Okay. All right, so if I were to do a log rule and get this in exponential form, so we start with the base, what it equals, what's left. We're going to have something that looks like this. So 2 to the x equals negative 1. And now let's think about this, okay? Let's try and solve this. So if I put in a positive number, so let's say I put in 2 for x, 2 squared is going to give me a 4. And 4 is a positive number, right? If I do 2 to the third, that gives me 8, which is a positive number. I could do 2 to the first and get 2, and that gives me a positive number, okay? So putting in a positive number for x won't work. It won't give us a true statement, okay? So positive numbers are out. All right, let's try 0. Let's put 0 in for x. Remember, anything to the power of 0 is always... Okay. Anything to the power of 0 is 1, positive 1. So 0 is not going to work. Let's try doing a fraction in for x. So let's do like 2 to the power of 1/2. Remember, the power of 1/2 is just a square root. Square root of 2 is like 1.14 or something like that. Not going to work. Not going to give us a negative number. Let's see. We've tried positives. We've tried zeros. Let's try negative numbers. Let's put in negative 1 in for x. We know negative exponents flip to the bottom, so this is going to become 1/2. I could do 2 to the negative 2. Again, flip that to the bottom, and it becomes 1/4. There's no number that I can plug in for x that will give me a negative number in return. Okay, so this rule is super duper important. You can never have an argument that is negative. It has to be greater than 0. Okay. All right. So I have a couple problems for us to talk about today. We're going to be solving some logs today. Before I show you the new stuff, I just wanted to refresh your memory on solving exponentials. So remember, when we were solving exponentials, the first thing we tried to do is make them have the same base. And then once the bases were equal to each other, we could set our exponents equal and solve from there. All right. So today, like I said, we're going to be solving logs. Here's the first one we have. So we have log base 5 of 3x minus 4 equals log base 5 of 2x plus 6. So we're going to kind of use that same idea up here. So where we have the bases the same, we could set our exponents equal to each other. With logs, once the bases are the same, so just like before, this time we can set our arguments equal to each other. So when your bases are the same, you can set your arguments equal to each other. So let's go ahead and do that and solve. So my arguments are equal to each other. Let's see, I'm going to add 4 to both sides. Subtract 2x from both sides. And it looks like I get 10 for a possible solution. Now, you guys are going to dread hearing this, but we need to check our answers. And we don't really need to check that the math works out or anything like that. What we need to check is that when we plug these in, it doesn't make our argument negative. For example, when I plug 10 into this one, I'm going to get 30 minus 4, which is 26, which is a positive number. So when we plug 10 into this one, it works out. It's okay. Let's do the same thing over here. So I'm going to plug 10 into my argument. And I get 20 plus 6, which again is a positive number. So because when we plug 10 in and both of our arguments stayed positive, we're okay with 10 as an answer. Okay? So when we check, we only want to make sure that these are positive numbers. All right, let's go ahead and do another one then. So we have log base 2 of x squared minus 4 equals log base 2 of 3x. So again, following that rule, when our bases are the same, we can set our arguments equal to each other. So I'm going to have x squared minus 4 equals 3x. And hopefully you're seeing that x squared in there and saying, oh, this is quadratic. I need to factor this. And remember, in order to factor, we need to have it set equal to 0. So I'm going to go ahead and subtract this 3x from both sides. All right, so let's go ahead and factor this. So I have x times x will give me an x squared. And let's see, 4 and 1. So I'm going to have a negative 4x plus a positive 1x will give me that negative 3x. So here's how I'm going to factor it, and that's set both of those factors equal to 0 and solve for x. So my two potential answers, I get 4 and negative 1. But again, I need to plug these back in and make sure that when I do plug them in, my arguments remain positive. So I'm going to check 4 first. So let's say I'm going to get 16 minus 4 is 12, which is positive. So we're happy with that. When I plug 4 in over here, I get 12, which is positive. We're happy with that. So 4 has checked out. It works. All right, let's go see this negative 1 now, okay? So I'm going to plug, I'm going to plug negative 1 in for here first. So let's see, negative 1 squared is a positive 1, and positive 1 minus 4 is a negative 3. Again, we cannot have arguments that are negative. So, because when we plugged negative 1 in, it gave us a negative argument, this means that negative 1 is one of those extraneous solutions. Our math is beautiful, but it just doesn't work in the situation. Okay, so this one actually only has one solution. It only has 4 as a solution. Negative 1 didn't work because it didn't give us a positive argument. All right, have a great day, guys.